Hello, welcome back. So, in this part, now we are going to learn more about finding resultant of several forces, which means if the number of forces acting on a body is more than two, in that case, how do we find out resultant? So, in that case, resultant can be find out using the parallelogram and triangular law also, but finding resultant of several forces, which is more than two, will be quite difficult and time consuming. So for that, we use another law. So based on that law, we find out the resultant. So the another law which we are going to learn is Polygon law of forces. And generally this Polygon law of forces is followed when there are n number of forces. So according to this law, the statement of this law is, it says if a number of concurrent force is again, all the forces will be acting on the same point, on a single point. So those forces are known as concurrent. So it says if a number of concurrent force acting simultaneously on a body, and if they are represented in magnitude and direction by the sides of a polygon taken in the order, then the resultant is represented in the magnitude and direction by the closing side of the polygon taken in opposite order. So this polygon law is actually the extended version of triangular law. So like in the triangle, we are having two forces, and both of these two forces, if they represent two sides of the triangle, then the third closing side will be represented by the resultant and in the opposite order. Now in case of polygon law, it says if some forces is acting on a point, so if we represent those forces in terms of polygon or in the form of sides of polygon, then the closing side of the polygon will be represented by the resultant. So now we will understand this statement more by when we look at the photo. So look at this photo. In the photo, you can see there is a hook which is attached with three chains, chain 1, chain 2, and chain 3. So you can see these all three chains are offering, or they are subjected to some force. Like this chain is subjected to force F1, the middle chain is subjected to force F2, and the third chain is subjected to force F3. So all three forces are acting on this hook. So now if we want to convert all three forces in a single force, then that single force will be the resultant force. Now in this case, you can see, how do we find out the resultant? So resultant can be find out using parallelogram law also. How? You can see, first we will consider F1 and F2. So if we consider F1 and F2, then their resultant would be between these two forces. Okay, then we will consider this resultant and the third force, and then we will find again apply the parallelogram law. So in that case, the resultant of this and force F3 will be Fr, which will be this one. So this force will be the resultant force of these three forces. Now if we try to represent these three forces along with the resultant using the polygon, how do we do that? You can see the same system I have shown here also. So all the forces, you can see here, all the forces are represented as, if there are three forces, you can see F2, F1 and F3. So F1 and F2 resultant would be F1 plus F2. Similarly, now as we have calculated resultant, now we will consider F1 plus F2 and F3. So the resultant of these two forces will be Fr. Now if we represent these in the form of polygon, say for example, force F2 direction is this one. Similarly, force F1 direction is like this one. Then force F3 direction is this one. So you can see all the forces are going in order, and now there are only three forces, F2, F1 and F3. So their resultant would be the closing side of the polygon, and that will be in the opposite order. So this is what this statement is saying. So now again you can read the statement and you can follow the same. So that is the statement that is based on the Polygon law of force. So Polygon law of force is used when there are more forces like 3, 4, 5 or even 10 forces, 15 forces. So if we have to replace all those forces with a single force, in that case what we can do is we can represent those forces in the form of sides of the polygon, and the closing side will be represented by the resultant. So that is the statement which is being written here. Now to find out the resultant of several forces, we actually use the method of rectangular components. So now to find out the resultant of several force, we will use the method of resolution of force through the rectangular components. Now what is rectangular components? Basically, if there are inclined forces, what we can do is we can convert these inclined force into their horizontal and vertical components. So like this force is inclined, so this force will be uh, distributed into two components. One is the horizontal component and the second one is the vertical component. So these components are known as rectangular components. So I will show you that in more detail. So as it says, when a force is resolved into two components along the x and y axis, the components are then called rectangular components. So in the figure you can see, say there is a force F, and this F is in the xy plane. So the component of this force along the x-axis is represented as Fx. Similarly, the component of this force in the y-axis is represented as Fy. And also the angle of this force F with reference to x-axis is given as theta. So you can see uh, there is a triangular formation. So in the triangular formation, the base is represented as Fx and the perpendicular is equivalent to the value of Fy. So if this value Fy, this value will also be Fy. So Fx in this case can be written as F cos theta, because Fx is representing the base of this triangle. So using the triangular relation, we can write Fx as F cos theta. Similarly, Fy can be written as F sin theta. Now, why I'm writing this? Because as I said that all the inclined force, if they are in any particular quadrant of the xy plane, then they will form like this triangle, and this triangle is actually the right triangle, and we can easily use the basic trigonometrical function like sine, cos, tan. So cos is base upon hypotenuse. So hypotenuse here is F and base is Fx. So cos theta will be Fx upon F. I am writing here cos theta will be Fx upon F. So we can write Fx is equals to F cos theta, which is this one. On the same way, we can find out Fy. So finding the component of the force in this manner, they are called rectangular components. So if there are n number of forces acting on a point, in that case, what we can do is all the inclined force can be converted into horizontal and vertical component, and then we can find out their algebraic sum. So we will see that the same in the next slide also. Sometimes like in the first case, force is represented I mean the direction of the force is represented by this theta. Sometimes theta may not be given, and the direction may be represented by this small triangle formation. So this small triangle, this one, this small triangle is similar to the bigger triangle, which is like this one. So in that case, how do we find out fx and fy? So that we will see in the next slide. So as I said, for analytical work, we can represent these components in one or two way using either scalar or Cartesian vector notation. So the vector notation that we are using, fy, theta, fx, or this one, so these are the part of scalar notation. We will not use Cartesian vector notation in our course. We will resolve the forces using the scalar notation. So all the notation that I'm using, fy, theta, and these proportions, so they are the part of scalar notation. So we will do that. So now rectangular component of force F as shown in the figure, they are found using the parallelogram law, so that F is equals to Fx plus Fy. You can see here, this F is actually the sum of Fx and Fy. So this is again a special case of parallelogram law. Well, I forgot to tell you, in the parallelogram law, there are three special conditions. When the alpha is 0, in that case, F1 plus F2. When the alpha is 90 degree, in that case also, this is F1 plus F2. Under root F1 plus F2. And when alpha is equals to 180 degree, in that case, F1 minus F2. I will explain more about it in the later stage, but these are actually a special case of parallelogram law. So in this case, this is again the sum of F is equals to Fx plus Fy. It is actually the special case of parallelogram law. So because these components form a right triangle, they can be determined, as I explained in the previous case also, Fx as F cos theta, Fy as F sin theta. And I have explained, sometimes instead of using the angle theta, sometimes the direction of F can also be defined using a small slope triangle, as in the example. So this small triangle is actually showing the slope of this force. So in that case, how do we find out the value of Fx and value of Fy? Well, in that case, you can see here, the force is making a bigger right triangle, this one. So if we want to find out Fx, so we can write this value is Fx, but this value will also be Fx. Okay, so if we want to write Fx by F, this Fx and this F, the whole triangle, I am just making here. This is the triangle and this is the triangle. So the whole F and Fx, Fy and A, B, C. So Fx by F, the ratio of Fx by F will be equals to the ratio of A by C. So this ABC value will be given. So instead of this theta, you will be given this value ABC. So using this relation, you can find out the value of Fx. Similarly, if you want to find out the value of Fy, so the ratio of Fy with respect to F will be equals to B upon C. So you can see the Fy line is this one, and parallel to this side, I am taking B by C. Similarly, for Fx, the parallel, this is the side, so parallel to this side it is A. So that is why I have taken A. So I hope now it is clear how do we find out the value of Fx and Fy, because Fx and Fy is the components of the force and they will be used to determine the resultant of the forces. So you can see here, I have just explained in the previous slide, Fx by F is equals to AC, and further we can write Fx is equals to F into A by C. Similarly, Fy is equals to F into B by C. So this is how we can find out the horizontal and vertical components of the force. Now we will see if there are n number of forces acting on a point, how do we find out resultant of those coplanar forces using the rectangular component. So till now we have seen rectangular component of only one force. Now if there are n number of forces acting on a plane like this, in this case you can see there are three forces acting, F1, F2 and F3. Now if we want to find out resultant of all these three forces, how do we do that? Well, we have to find out the horizontal and vertical component of all three forces. So the horizontal component of F1 in terms of x will be F1x. Similarly, the vertical component of F1 will be F1y, like this one. You can see here this diagram. Now it will clear more. This is the actual case. Blue line force are the actual force, and these force are now converted into the two components, the horizontal one and the vertical one. So F1 is converted into two components, F1x, F1y. Similarly, the force F3 is converted into two components, F3x, F3y. Similarly, the F2 force is converted again into two components. F2y is the vertical one and F2x is the horizontal one. So now to find out the resultant, what we are going to do is we will find out the algebraic sum of all the horizontal component, which means all the x component force, and algebraic sum of all the y component force. Now how do we do that? That we will see. See here, first of all we will find out summation of all the forces along the x-axis. Now along the x-axis, before that I will tell you what is the sign convention that we are going to use for our analysis. Generally, upward force and rightward force, they are considered as positive. Similarly, leftward force and downward force, they are considered as negative. Okay, so now you can see the summation of fx. Now first force F1x, it is rightward. Rightward is positive, so I have taken F1x as the positive. Similarly, the force F3x, this one, F3x is again rightward, this rightward. So again I am taking this as positive. But the component of F2x, this one is leftward, which is negative. So that is why I have taken minus F2x. So the summation of Fx becomes F1x plus F3x minus F2x. So that is the summation of horizontal force. So first what we have done is all the inclined force are converted into horizontal and vertical component, and the next step would be to find out their summation along x-axis, summation along y-axis. So the summation along x-axis is this one. Now summation along the y-axis is this one. So now you can see F1y and F2y, both of them are upward. So that is why F1y and F2y, they are considered as positive. Similarly, F3y is, the direction of F3y is downward. So I have taken that as negative. So please remember this sign convention. Upward force and the rightward force, they will be considered as positive, and downward force and leftward force will be considered negative. And on the basis of this sign convention, we will find out the summation along the x-axis, summation of forces along the y-axis. Now once we find out the summation, then what we have done, actually we have actually done, now there are three horizontal force, F1x, F2x and F3x. So all three forces are converted into single force. That will be summation of Fx. Similarly, we have three vertical force F1y, F2y and F3y. So what we have done is we have converted these three forces into a single force, which will be summation of Fy. So now we will represent summation of Fx and Fy in the diagram, because now they becomes only the two force, one along the horizontal and one along the vertical. So that you can see now. So this Fx and Fy, it can be written as resultant component, component of resultant force along the x-axis, which is summation of Fx, component of resultant along the y-axis, which will be summation of Fy. So this Frx is actually this one, this value, and this Fry, this Fry is actually summation of Fy. So if both the value is positive, then they will fall in the positive quadrant. So I hope now you know that this is positive, 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 negative, and negative, 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 positive. So these are the quadrant that we see. So in the first, this is the first quadrant, this is the second quadrant, and this is the third, and this is the fourth. So in the first quadrant, both are positive. In the third quadrant, both axes are negative. In the second and fourth, one axis is positive and one axis is negative. So that depends now. If our value of Fx is negative and value of Fy is positive, so in that case, the resultant will fall in the second quadrant. If the value of Fx and value of Fy is positive, then the resultant will fall in the first quadrant. Okay, so this is how we decide where our resultant will lie. So resultant, so we are assuming that summation of Fx and summation of Fy is positive. So that is why I have shown this blue resultant force in the first quadrant. And this resultant force will also be having a direction with reference to the x-axis. So how do we find out this direction? So you can see this resultant force can be is actually making the right triangle, and right triangle is having angle theta, and this vertical can be represented as Fry. So this value and this value will be same. Similarly, this value is Frx. So in that case, what is the resultant? Well, you can see here, I'm just showing this triangle. This is Fr, and this is showing the Fy, and this is showing the Fx, and this is showing the theta. Now we have to find out Fr. So you can see this is the right triangle. We can simply apply the Pythagoras theorem. So according to Pythagoras theorem, Fr is equals to under root summation of Fx square plus summation of Fy square. So this is the magnitude, this is the expression to find out the magnitude of the force. Similarly, to find out the theta, theta will be tan theta is summation of Fy upon summation of Fx, and theta, if we send the value of tan on the right hand side, then the expression of theta will become like this one. Okay. So this concept that we have discussed now, it will be illustrated numerically in the next example and in the next part. Thank you.